This is a short update movie to tell you what we've been doing with our IoT sensor data. So in the previous movie, we had a Raspberry Pi with a heat sensor attached to it, and we were streaming the data from that Raspberry Pi and putting it into a smart contract. And the interface looked very much like this one. So we've now taken a lot more data and put it into these set of contracts. So we have all the sources for our greendata project solar panel sensor information. So there are a whole series of solar panels on the greendata project streaming information currently to a database, and we have fed all that data daily aggregated into a set of contracts, smart contracts on our blockchain. And so here in the interface, you can see a lot more data than you saw in the last one. We have a whole list of sources this time, some of them with multiple feeds. And so the map looks a lot more interesting. We've got many more sources of information. So the interface hasn't changed really since the last version. You can still pick a feed and you can view its daily aggregated data, see what kilowatts of power came in for that particular panel. But this time, because we had lots more sources and feeds, we wanted a more aggregated overview graph as well. So we created this cross-filter view where you can see all the data for all the feeds from all the sources in one view, and you can filter it. You can filter it by time, you can filter it by source, by day, by month. And at the bottom, as you filter, you get just the data input points for that filtering. So this was just a way we could sort of explore all the data coming in. Now, when we were trying to create this view, one of the problems we had was with this volume of data inside the contracts, the way we structured the contracts, the data was being pulled out far too slowly. It took too long for this drawing to come up. And we have found, particularly with our RDF experiments, and there'll be a separate movie to do with that, that storing the data inside structures and then arrays of structures inside a smart contract is much slower to pull out than if it's a series of mappings. So if we take a quick look at our original feed contract where all the base data goes, you can see that what we actually had to store the data was a structure, and it had an identifier, the timestamp, and the data point associated with it. And then that was kept in an array. So all the data points got added into this array in this format. But as I say, pulling that out was incredibly slow. So in this iteration, we stored the data in a series of mappings instead, and a mapping is a bit like a hash table. And as well as that, we broke it down into chunks of 60,000 records because we found it was much quicker to pull them out in chunks in this format than it was before. So we were able to get all the data we needed for our overview drawings much more quickly. So that really is the main innovation between the previous movie about our IoT sensor data and this one about our solar panel data.